Hey class, in today's lesson we're talking about ratios. By the end of today, I'm hoping you can write ratios to describe relationships and identify if those relationships are part to part or part to whole relationships. So first thing, we're going to review the difference between a fraction and a ratio. A fraction, which you're familiar with, always shows a part to whole relationship. It never shows a part to part relationship. For example, if you think about like a simple pizza cut into 4 pieces and you eat 3 out of 4, it is always a part to whole relationship. 3 is the part, and out of the total of 4 is the whole. A ratio, on the other hand, sometimes shows a part to whole relationship, but sometimes shows a part to part relationship. And we'll look at that more in detail as the lesson goes on. So here's our first example of a ratio. We can write the ratio of car number 1 laps to car number 2 laps in 3 different ways. So first, when car 1 is on lap 1, car 2 is on lap 4. Car 1 is on lap 2, car 2 is on lap 8. When car 1 is on lap 3, car 2 is on lap 12. So these cars share a 1 to 4 ratio. For every 1 lap car 1 does, lap 2 does 4 laps. And you can write that in 3 ways. You can write the ratio as a 1 to 4, like that. You can write it with a semicolon, 1 to 4. And sometimes you can write it as a fraction, or sometimes it's written as a fraction like 1/4. Notice that we can solve if we wanted to say, okay, car 1 is on lap 6 now. What lap would car 2 be on? Since it is a 1 to 4 relationship, that means that car 4 does 4 laps to every 1 lap. So it is a multiplier by 4. So if car 1 is on lap 6, then that means that car 2 would be on lap 24. All right, so let's practice writing some ratios. If there are 12 girls in a class of 26 students, what is the ratio of girls to total students in the class? So since this is a part to whole relationship, girls are part, the whole class is the students. So this is part to whole. So you can write this as a fraction or as a 12. There's 12 girls to 26. Or you can write it as 12 semicolon 26, or you could write it as a fraction. Sometimes I like to use the fraction because then I can see that this ratio can actually be simplified. So similar to simplifying fractions, we can simplify ratios. If there are 12 girls for every 26 students, that means I can divide these both by 2, and that means there's a 6 to 13 ratio. So that would be an equivalent ratio, 6 to 13. For every 13 students, there are 6 girls. So for 26 students, there are 12 girls. Similar problem, if there are 12 girls in the class of 26, what is the ratio of girls to boys in the class? This one is a part-to-part relationship because it is part girls and boys are part of the class as well. So if it's girls, we're writing the ratio of girls to boys, then there are 12 girls to, there were 26 students in the class, take away 12 of them that are girls, that means that there are 14 boys. So you had to do a little bit of thinking there first. But this is an example of a part-to-part relationship because there are girls to boys. So it could be written similarly, either way you want to write the ratio. This one also simplifies because 12 and 14 are still both divisible by 2. So you could simplify this to say there's 6 girls to 7 boys. So for every 7 boys, there are 6 girls. 14 boys, there's 12 girls, etc. So that is a part to part instead of part to whole. That's the difference. Okay, make a comparison with ratios for the sets of these cards. Let's write a ratio with the cards with hearts to the cards with diamonds. So I have 2 cards with hearts right here. 1, 2. And then I have 1 card with diamonds. So my ratio of hearts to diamonds would be 2 to 1, or written as 2 to 1. Cards with diamonds to cards with clubs. So clubs are this symbol that you see, kind of the looking snowflake, four-leaf clover. That's clubs. If you're looking at more cards, there's like an upside down one. That's called spades. So we have the hearts, diamonds, and then those are clubs, and those are spades. So diamonds to clubs, there are 1 card with diamonds to 2 cards with clubs. So I'm just counting the number of cards. Cards with hearts to cards with clubs. There are 2 cards with hearts to 2 cards with clubs. This one simplifies to a 1-to-1 ratio. For every heart you have a club. They match up. There's 1 here and 1 here, 1-to-1. So you can simplify that ratio. Ratios of cards with hearts to all cards. So the first 3 examples were all part-to-part relationships. Part-to-part, because it compared one part of the 5 cards to another part of the 5 cards. You'll see the last 2 have cards with hearts to all cards, spades to all cards. So these last 2 are examples of part to whole relationships. There were 5 total cards. So hearts to cards would be 2 cards or hearts to 5 cards total. Cards with spades to all cards. Remember, spades was this symbol here. We actually have no spades cards. So this is a 0 spades to 5 cards. So that would be that one. So it is the ratio actually is just 0 because there are no spades cards. All right. Let's practice writing more ratios. If there are 14 bags in a bag of if there are 14 apples in a bag of 26 apples and oranges, what is the ratio of apples to total fruit? So since we're comparing to total fruit, this is a part to whole relationship. And we have 14 apples to 26 total. So that would be our ratio, which we could also write as 14 to 26, or we can write as 14 out of 26 total. This can be simplified by 2, so it's the same thing as 7 to 13, or 7 to 13, or 7 to 13, like that. So it has a reduced ratio, but it's a 7 to 13 ratio of apples and total fruit. If there are 14 apples in the bag of 26 apples and oranges, what is the ratio of apples and oranges? This is a part to part relationship because we're comparing apples and oranges in a total of apples and oranges. If we're comparing apples to oranges, then there are 14 apples to, there was 26 total, take away 14 that were apples, that leaves me with 12 that are oranges then. So it's a 14 to 12 relationship, or 14 to 12 written like this, or 14 to 12 written like this. That does reduce to 7 to 6 ratio, 7 to 6 ratio, or written like that, because 14 and 12 can both be divided by 2, so we can reduce that ratio as well. All right, one more practice here. At the movies, the ratio of small popcorn to large popcorn is 4 to 9. Small to large, 4 to 9. For every blank large popcorn, there are how many small popcorns? So at the movies, the ratio of popcorn, small to large, is 4 to 9. So that means that 4 to 9 is small to large. So you have to be careful the way that it's read, which means for every 9 large popcorns, there are 4 small popcorns purchased. At the baseball game, the ratio of hot dogs sold to hamburgers sold was 5 to 4. So that's ratio 5 to 4 was hot dogs to hamburgers. Hot dogs to hamburgers. For every 4 hamburgers sold, then how many hot dogs were sold? So for every 4 hamburgers sold, there were 5 hot dogs sold. So I would answer that question. All right. Next week, we'll talk about using ratios to help us solve problems. Thanks for watching.